The substance inside the beaker is sucrose or table sugar. The liquid being added is concentrated sulfuric acid, which is very dangerous and must be handled with care. Also, toxic fumes are released by the reaction. Therefore, please do not try this reaction at home. Notice that even though the reactants are colorless and white, the product is black. Also, gas was released and the area surrounding the reaction became extremely hot. To find out why these things occurred, we will explore the chemistry behind this reaction.
The sulfuric acid dehydrates or removes water from the sucrose molecules. Sulfuric acid is a strong dehydrating agent and will pull water molecules from carbohydrates such as sucrose. The overall chemical equation is as shown.
The reaction produces carbon dioxide, water vapor, and sulfur dioxide. Sulfur dioxide is a poisonous gas, which is why the reaction was performed in a fume hood. The yellow color observed before the mixture turns black likely comes from an intermediate step in the dehydration reaction. As the sucrose molecules are dehydrated, heat is generated by the reaction, which turns the water into steam. The mixture eventually turns black because carbon is black. The rising steam expanded the carbon in a porous black column.
Since the reaction releases energy in the form of heat, this means that it's exothermic. This is because the products are more energetically stable, or lower in energy, than the reactants. The change in enthalpy is marked by delta H, and can be thought of as the amount of heat transferred to the environment since conditions were under constant pressure.
Sulfuric acid catalyzes the upper reaction, which represents the dehydration of sucrose, meaning that it increases the rate of the reaction but is not itself consumed. Thus, it is shown above the arrow in brackets.
The lower reaction is an example of a redox reaction, or an oxidation-reduction reaction, meaning that a transfer of electrons occurs. Since sulfuric acid was consumed in the reaction, it is shown in the chemical equation. The carbon in elemental carbon is oxidized into carbon dioxide, meaning that the carbon atom can be thought to lose electrons, thereby becoming more positive in charge, since electrons bear negative charge. Oxidation reactions are always accompanied by a reduction reaction, since charge must be conserved. The sulfur in sulfuric acid was reduced to sulfur dioxide, meaning it can be thought to gain electrons and become more negative in charge.
Some sulfuric acid was still present in the carbon column and beaker. Sulfuric acid is very corrosive, so to dispose of the products, we neutralize the remaining products with sodium bicarbonate, which is a base. The chemical reaction of this acid-base neutralization is shown. This process took a substantial amount of time since the sulfuric acid was concentrated. Once it was neutralized, we could dump the products down the sink. Thanks for watching!